now that we've talked about our exponential functions and how to do transformations to them, let's talk about our log functions. And we have actually learned 3 different variations of log functions. The first one is that f of x is equal to log of x. And remember, that's an implied base 10, our common log. The next one is our more general log base b of x. And finally, we have our natural log of x, which is a log with a base that is the natural base e. We can start with any of these forms, and in fact, in your examples that you have here, you will see that they show you all 3 forms with the same transformation. So you can see what it looks like in all 3 forms. Very, very similar. If we have a horizontal translation 4 units right, it's always going to be a -4 right there in parentheses. So in this case, x and inside with x means inside the parentheses, as it has typically meant. So take a look at these if you need a refresher, but we're going to go ahead and move on to describing some transformations that we see. Let's look at some examples. For this first one, I'm starting with log base 6 of x. So that's my more generic log base b of x form. And my transformed function is log base 6 of x plus 4 minus 1. So just like before, I want to identify the things that are different. I see a plus 4 inside the parentheses with x. Remember that inside is always going to affect our horizontal values, and this is going to move us left by 4. The opposite of what you'd think. Positive is left. I have a -1 tacked on the end. A -1 is down 1. Now here's where things can get a little tricky. Remember that for our exponential functions, we had a horizontal asymptote for our parent function at a y value of 0. But for our log functions, the asymptote was actually vertical along the y-axis at x equals 0. So now, in order to figure out what change might have happened to our asymptote, we need to look at things that have happened that change the x values. And I see that I have moved my function left by 4. So that is a -4. We have gone to a -4 from an origin point of 0. So my asymptote is that x is equal to -4. Now remember, on these log functions, it's also not going to be the domain that's all real numbers. It's the range that's all real numbers, and the domain that is affected by our asymptote. So range is all real numbers, but domain is going to be x greater than -4. Remember that we have shifted our asymptote from a value of x equals 0 to a value of x equals -4 with this left by 4. Okay, let's take a look at another one. So I have f of x is equal to log x, so this is my implied base 10, and my transformed function is -log x plus 3. So the first thing that I see is a negative sign out in front. And remember that when there's a negative out in front, not inside parentheses with x, in front of x, but out in the very front, that's going to be a reflect over the x-axis. The next thing that I see that's different is I have a plus 3 tacked on the end, which is going to move me up by 3. Now both of these transformations affect vertical values only. Remember that reflecting over the x causes positive y values to become negative y values. Moving up by 3 is going to also affect y values only. And so my asymptote, which is at x equals 0 for my parent function, isn't going to change here. I haven't done anything to move myself to the left or the right, or to reflect over the y-axis. So my asymptote is still in the same place that it was for my parent function at an x value of 0. Domain is therefore x greater than 0, and range as always for log functions, all real numbers.